Hello and welcome to my YouTube channel. Today in this video we are going to prove Cantor's theorem. Now what is Cantor's theorem is there is no surjection, that is an onto map from x to p of x. Now x is any set and p of x is subset power set of x. Power set of that set x, which is a collection of all possible subsets of x. So we have to prove that there does not exist any surjection, that is any onto map from x to p of x, which is equivalently of showing that cardinality of this set x is strictly less than cardinality of p of x, and therefore the power set, if we make a power set of x, the cardinality of if we take a power set of x, its cardinality will be bigger than this. So this, through this theorem we can able to also say this thing. Now let's prove it. Coming to the proof of Cantor theorem, we will prove it by contradiction. Let me assume, supposing that, suppose there exists a surjective map f from x to p of x. A, which is all, we are taking one subset of x such that it does not, what will be its pre-image, like this set will give a contradiction. With the help of this set we are able to get into the contradiction of our assumption, and hence our theorem has to be true. This is how we go for proof by contradiction. What is the step for proving proof by contradiction is that we first assume the wrong thing, and by proving that false statement we will get a contradiction, and hence we will say that this is a false, the other one, that the other side is true. So let's start. A is all such x belongs to x such that x does not belongs to f of x. Now this is a subset of x, which implies that A belongs to p of x, because p of x is a collection of all subsets of x. Now because it's a surjective map and p of x belongs to p of x, there must exist, for this A there must exist a here in x. So there exists A belongs to x such that f of A is equals to A, because we have a surjective map. For every set here we have its pre-image. Now also this x, A belongs to x. X can be a union of A union A complement. Writing it equivalently such that f of A is equals to A. Now x belongs to A union A complement. That means x can be A belongs to A union A complement. That means we have two choices. Either A can belongs to A or A does not belongs to A. That is, A belongs to A complement. Does not belongs to A means A complement. So if A belongs to A, now A is my f of A. If A belongs to f of A, that means A does not belongs to A, because if A belongs to f of A, we have the A is a collection of all such x in x, so that x does not belongs to f of x. So with the help of this, what we are getting, A does not belongs to A, which is a contradiction. Again with this, what we are, A belongs to A complement means what? A does not belongs to A, which means A is my f of A. F of A. Now f of A does not belongs to f of A means what? A belongs to A. A does not belongs to f of A means A belongs to A. From here you can see which is a contradiction. So A does not belongs to X, because if we are saying that A belongs to A, we are getting contradiction. A belongs to A complement, A does not belong. So A does not belongs to X. That is A union A complement, which is a contradiction. We does to that that F being a surjection. So our assumption is wrong. Therefore, there is no surjection from X to P of X, which says that there must exist an element here which does not have a pre-image here. This is necessary. There always exists an element here which does not have a pre-image here under any function f from X to P of X, which also says that cardinality of X is always less than cardinality of P of X. Because if the other side is wrong, because for surjection we say cardinality of no surjection means this will happen. Because if cardinality of X is greater than equal to cardinality of P of X, there will definitely exist a surjection. The one will be the identity map, not identity map, it is possible for these cases. Okay, thank you so much.